I will not accurately throw it.
Yay, thank you.
I was going to say, your catching ability is not what's in question in this particular equation. What's up? Say that again? Yeah.
Who's gonna test it? Oh yeah. Not good. I can tell.
You sucked today.
Is Kate sitting by myself in the corner? Huh? 7? Thank you.
Do you get hit? Do you get hit? No.
All right. Locking in.
Yes, we're locked in.
So what this is going to be, what this formula is this is how we're going to get the sum. So this does a very similar thing as our sigma. Like this is still going to give us a sum from our k equals 1 to our n of whatever our a sub k is. This is going to give us the same thing. It's just using our recursive definitions for our algebraic sequences or arithmetic sequences. So what this is this is the symbol, this S. This is the sum, so we're going to add up, of terms to n. Sum of terms to n. And you don't have to memorize both of these equations. If we know this thing, and we remember the a sub n thingy that we were working with the other day, where our a sub n we get as our a1 plus n minus 1 times that common difference. If we do this as like a substitution right here, we 100% get to this equation down here. So taking this, our n over 2, or whatever this n is down here, that's the n. We take our first term and our last term and we add them together. And then we multiply them by n over 2. It'll give us our sum. And we're going to look at this here in just a second, seeing that this does in fact work. So getting from here to here is not mathematically challenging because we would just take our n over 2. The brackets are just parentheses on steroids. They're just bigger parentheses so that they get the height to get those sub numbers in. It's the only reason it's brackets instead of parentheses. The parentheses have a tendency to cut it off like right underneath the A, and just so that the sub numbers are covered. It's the only reason we use brackets. So it's not special. It's just parentheses. So if I do my a sub 1 plus, and then I substitute this guy in for the a sub n right here, we have our a sub 1 plus our n minus 1 times that common difference. I have a sub 1 plus a sub 1. That gives me 2 a sub 1s. Plus n minus 1 times d, n minus 1 times d. So it is the exact same thing. These two pieces are the same. They just substituted this piece in. So we'll use pretty much this one if we know our common difference. And we'll use this one if we know our values. Pretty much. So we're going to explore this here for a second before we really get cruising with the formulas. I want us to see that this does work and why this does work. So I'm going to give us a finite series. So we're going to look at this guy right here. So we've got 2, 5, 8, 11, 14, 17, 20, and 23. This finite individual series. So I want us to find the sum of this sequence. We're finding the sum. So we could add them together. Type this sucker in the calculator. 2 plus 5 plus 8 plus 11 plus 14 plus 17 plus 20 plus 23. Do that. Really. we get 100. So when we have finite series, sometimes we can just add them together. We're going to get the same answer if we use that series formula we just had. So that sum of the series, how many terms do we have here? We need that bit.
Like 7. Wait, not, wait, 8.
I was going to say we've got 1, 2, 3, 4, 5, 6, 7, 8. So we're going to get the sum of these 8 terms using our n over 2 times our a sub 1 plus our a sub n, 8. So I know a sub 1. What's a sub 1? 2.
That's 25.
So we have, you're just jumping ahead of me. So my a sub 1, that's our first term in the sequence. That's this guy, that's the 2. And we know our 8th term in the sequence. It's that 23.
I thought policy sub 3.
In the, it's going to be our a sub n.
Oh, I read.
All good. That's part of the reason we're practicing it, because it helps us spot those little things in there before we get into the weird, complicated stuff. And 8 divided by 2, we know that is going to be 4. So what is 4 times 2 plus 23? Bless you.
100. Thank you.
We still get 100. So on this one, it's probably faster for us to just add them manually. But if we had 100 terms, or if we had 900 terms, or if I just had like 15 terms and did zero typing, bless you, all those bits into the calculator. So it does the same thing. We get the exact same answer by taking our first and last term times our n over 2. Okay, so it gives the same pieces of information as just adding them together. So you could theoretically just list all the terms and then add them together, but that is a lot. So let's take this series formula, our S sub n, and we're going to use it a couple of times. So I've written this one for us up here, because sometimes we're just given what feels like very random data. So this is the simplified one where we did the substitution. We took this guy, we substituted in, we got it here. So we're going to do our a sub 1 of 40. We have our common difference is -3. And our number of terms that we're going to do is 30.
Oh, no.
So we've got an equation where we can just plug and chug these pieces in. We're going to get the sum of these 30 terms, that's our n, by filling in this data. We're going to have our n over 2, our 30. Don't shout out numbers while I'm writing, dude. We're going to have our 2 times our a sub 1, which is this 40.
Wait. Oh.
Plus our n, which is 30, minus 1, times that common difference of -3. Your other option is to go through and figure out what a sub 30 is and use the other equation, which is another valid option. It can be negative. Think about when we add up all the things that are in a line. If we have negative numbers, we'll end up with negatives. Yeah, it should be -105. So we're going to have our S sub 30. And if you need to, write it in pieces. We'll have our 15 times.
Insane.
What are we saying?
Insane, bro.
That was wild.
Yeah.
All right, so our final answer here should be our -105. So we're simplifying it in pieces. So here's another one. It can be fractiony. That's a thing that happens. So our first term is 7/3. Our common difference is -2/3. And we're doing 15 terms. Truth. It is indeed annoying. So substitute our pieces in. What in the world are y'all talking about? Oh my gosh.
Spanish speaker, by the way.
Okay, that was not
The extent of my Spanish knowledge is just about Yo quiero Taco Bell.
Hola. Oh.
Hola.
Yo quiero Taco Bell. It's from a commercial in the 90s. That is the extent of my Spanish knowledge for the most part. I took French for 3 years, so. Je m'appelle petit français, but petit. Because it's been 20 years since I did any French. I got that and a few groceries, and that's about all I got. And, though I can recognize curse words in most languages. Yes, many languages.
-35.
Say it again? Yes. 15 minus 1. Y'all are just faster than me, especially because I'm marking things down. Our common difference of -2/3. So we should be setting it up like this. And I know y'all are faster than me because I'm doing all the color changing. So what do we get as our sum of all these pieces?
-35.
We should wind up with a -35. We'll get 14/3 plus -28/3 times 15/2. Thir 35. Okay, it sounded like you said 55 for a hot second there. Like 55. That's okay. All right. So sometimes we won't just be handed things all nicely like this, or it's just plug and try. So we're going to find the sum of the even integers from 2 to 100. Okay, first things first, what are integers? Counting numbers. Think about like apples. 1 apple, 2 apple, 3 apples, 4 apples. Counting numbers, so the whole numbers. So our even integers are what? 2, 4, 6, 8, ... up to 100. That's where we're stopping. So this is our sequence. How many terms is that going to be? 50. Because it's every other number. Up to 100. So the number of terms are n number of terms is 50. So what's our first term? What's our a sub 1? 2. What's our a sub 50? 100. This guy is our 50th term. So when we're trying to find the what's up? We good? Because you're kind of loud in front of everybody. So our S sub 50, finding our sum of these 50 terms. I know my first term. I know my last term. I don't have to count out every single number between 8 and 100. We can take our n over 2, so our 50 over 2, and put in our first term. You know our first term, that was 2. Plus our last term, 100. So we'll have our 25 times 102 which gives us 2,550. Some of the numbers in this are going to get obnoxiously big just because we're adding things up and we're doing sums on things. So just so we're aware. Okay. You could also do this one with the other term, like with the other formula. We know how it's changing. Even integers are going to be up by 2. We could do it this way. My common difference is going to be a positive 2. So you could also do this one as our S sub 50 with our, sorry, I'm trying to get down, 50 over 2. And you could do it this way with our 2 times our A sub 1, which was our 2. The 50 minus 1 times that common difference of 2. You can do it this way. This is just using the other formula. It'll get you to the same exact answer. So you can do either way. This is the first term, last term. This is the, I base everything off of A1. Either way is fine, and you should still get to our 2550. So we have 2 different formulas that will work the same exact way because they're built off each other. So this is probably the easier way, but this totally works. Totally works. All right, let's do a little bit more practicing with our sums, because sometimes we'll see them like this. So we're finding a sum from 1 to 20 of 3k minus 5. The way we did this before, I found my term 1, my term 2, my term 3, found them all, and we add them up. This is an algebraic sequence. I'm going to show you how we can prove that for sure. So look at our terms. If I find my first term, my A sub 1, what are we going to get? How do we find our first term? Yeah, it would be, that's when we substitute the 1 in for k. So 3 times 1 minus 5, we get negative 2. What's going to be A sub 2? Because that's when we substitute 2 in here. 3 times 2 is 6 minus 5, we get 1. What's A sub 3? So how is it changing between here? Added 3. Added 3. So our common difference is 3. And in fact, whenever we have an algebraic sequence, should be our slope. Because it's only going to be an algebraic sequence if we have a linear statement right here. Because it needs to add each time, that's a linear statement. So because this is a linear function, this is algebraic, which means I can use one of those sum formulas we had so I don't have to find A sub 19, A sub 18, A sub 20, all the pieces. I just need enough things to fill in our formula. And we can use either one. You can either use, we get our sum from our n over 2 with our A1 plus AN. Or you can use the other one. N over 2, 2 A sub 1. Matching bracket. There we go. You can use either equation. We're going to need to find our A sub 20 for this piece, but we can do that. On this one, we would need to make sure we figure out our n and that common difference. Either way, we're going to get the same answer. Let's find our A sub 20 so that we can use this one, because we haven't used this one in a couple pages. What is A sub 20 going to be? Yeah, because if we substitute 20 in here, 3 times 20 gives us 60, minus 5 gives us 55. So when we're finding our sum of 20 terms, we can do this with our 20 over 2 times our a sub 1, which was negative 2, plus our a sub 20, which was 55. First term plus the last term times n over 2. So what do we get as our sum here? I bet you could. What's 55 plus negative 2? 53 times 10. 530. So you can use either one of these formulas for it. Okay. Dude, it's 9:25. No. We are not done. Nice try, though. What's up? What do you mean? Yes.
Like, shit, like 5, like 6 o'clock.
Yes.
Oh, man.
Why?
You can't come to Jazz Cafe.
Can't come to the what?
Jazz Cafe.
No, I cannot come to the Jazz Cafe. As I say, we have scouts, and I have much chair to fix, and all that jazz. So, no. Enjoy your jazz concert. All right. So let's look at this one. Very similar vibe. Find our sum. We have from 1 to 18 of 1/2 k plus 7. So find our first term and find our last term. That's probably the easy way to go. For my mind, at least. You can do it either way. You can either find our common difference and go with the second formula, or you can go with our first and last and use that one. So what is our first term going to be? I was going to say we're going to have our 0.5 plus 7. So we're going to have 7.5. Yep, we got to have the 7. So how about our 18th term? Yes, sorry, my brain got stuck there for a second. Yeah, 16. How many terms are there between 1 and 18? 18. Just making us think. So we're going to get our sum of these 18 terms. That's what the little number down there means. It's the sum of these 18 terms by taking our 18 over 2. It's always over 2. With our first term, 7.5, plus our last term, our 16. First term plus last term times our n over 2. What do we get as our sum of these 18 terms? Mm-hmm. We should get 211.5. Which, again, I could find each of these pieces and add them up individually, but that's a lot of work. I could come through and find our common difference. I could find the first two terms and figure out how it's changing in between. We could do that. So we have lots of options when it comes to finding our solutions for these. We have one last concept in this section that I want to make sure we touch on today. We will continue practicing with everything tomorrow to get ready for the last quiz of the semester. But I wanted to make sure we got to talk about everything today before we got there. So our last concept to have that we will continue practicing is called an arithmetic mean. So if we have a sequence, like I'm for here using our A, comma, B. Oops, sorry. The arithmetic mean of two numbers is the mean that we think of when I say mean, the average. I add them together, I divide by how many. When we're inserting a mean into a sequence, what we're doing is we're trying to fill in blanks in a sequence. Say, I have my first term is A, my last term is B, but I don't want to just have two. I need to divide this into smaller pieces. I need more things in between. So to insert an arithmetic mean into a series or a sequence, we are going to put it in between like this. So if I wanted to insert C into the middle here, then what we're going to do is we're going to find our new common difference here by figuring out these pieces. We need to figure out what that is, and we're going to use our formulas we've had for our series to do so. And I'm going to walk you through this several times. So we're going to start by naming the pieces. So we're going to put them in with letters, and usually we'll do like C1, C2, C3, if we need to put 3 of them in. And then we're going to find the new common difference using our A sub n formulas. And then we have to figure out those 3 values. So these are kind of our steps.
Thank you for that beautiful saying of yours.
So these kinds of problems are going to be pretty much like this, where it says insert 3 arithmetic means between 3 and -5. What this says is I have the set 3 minus 5. I need more data than that. I need more pieces in the middle. That's too big of a jump to make. I want to put 3 pieces in between. So I want to have my 3, and then I want to have 1, 2, 3 pieces in between before I get to my -5. You don't have to use C. You can use different letters if you want to, but we just tend to, since they're all kind of the same thought process. That's the way I tend to write it, and it's the way the book tends to write it. But if you use ABC, totally fine. If you use DEF, you use your own initials, you want to spell out a word because you're feeling a little froggy, go for it. I don't care. They're variables. You can use happy face, heart, and thumbs up for all I care. I don't recommend it. Thumbs up's really hard to draw over and over again. It looks like a mitten. I tried it. It's bad. It's bad. I tried it once. I do not have the skill to do emoji math by hand. Bad. Okay, so this is what we want our sequence to be. So instead of this being our first term and our second term, now what we have is our first term, our second term, our third term, our fourth term, and our fifth term. So we want to figure out what the common difference is, but the only ones we have numbers for are A5 and our A sub 1.
So it has to have like a pattern. It has to go down.
It will be a pattern. So we will be very specific that it has to be the arithmetic mean, because I can't just pick random numbers in between. It has to divide it equally to make this be an algebraic sequence, arithmetic sequence. So what that means is we're going to use our formulas we had, like our A sub k. I want to make sure I put the letters in the same. Do we have it as an N or do we have it as a K first? I genuinely, my brain is not working. That's our common difference. There it is, A sub N. There we go. Which we get from our A sub k and minus k times d, this guy. Or you can use the A sub 1, but only if we have A sub 1. We do, but that's okay. So what we're going to do is we're going to use the pieces we have to figure out what the common difference is. I know 2 terms. I know my first term and I know my fifth term. We're going to solve for D. So I'm going to put my A sub 5, just because I traditionally like to do the bigger one as the equal sign. It doesn't really matter. So we're going to have our A sub 1 here plus our N. What are we being hypocrites about 3 feet from my face? All right, so those are pieces I know. So I can substitute those pieces in. I know A sub 5. A sub 5 is going to be our -5. That's a guy we know. And we know the value of our A sub 1 as well. It's 3. Plus our N of 5 minus our 1 times that common difference. And that common difference is what we're trying to find here. So let's solve this. What are we going to do to solve this for D?
5D minus 3 is 4D.
Mhm. Yep. So we've got our -5 equals 3 plus 4 times D. Subtract our 3 from both sides. We've got our -8 equals 4 times D. So what is our common difference here? -2. But then I need to figure out these values in the middle. So this is how it's changing each time. So if I know that my first term is 3, what's my second term? What is C sub 1 or A sub 2? What's my next piece? Because we take our 3 plus that common difference. Our common difference of -2.
Is that an E or a T next to an E?
That's a plus. So would be 1. So C sub 1 is 1. So I could put in this spot. We're finding our next pieces here. That's a plus. My -2.
That one, the one next to like the negative T equals a T.
Say it again.
Like that one with the negative.
That's an arrow. I was talking about our common difference. That's when it helps to watch what we're doing. It was an arrow I was using while I was talking. So what's our next term? What is our C sub 2?
Negative.
And C sub 3? Hang on a second. What is 1 minus 2? -1, not -2. And then -3, because we should wind up at -5. It puts these all into order and makes this be an algebraic sequence. Arithmetic sequence. Why? I keep switching those two in my head. Oh my goodness. 1, -1, -3, -5 is our new sequence. So that's what it means when it says insert arithmetic means. Okay? We are going to practice with all of this again tomorrow. I just wanted to make sure we had all the pieces we need to be able to approach the homework, approach what we need to get ourselves ready, because we have a quiz coming up this week. It is over more than one section. So,
We have a quiz.
wait, and last quiz.
So we should.
You're trying to leave.
We just took one.
A graph, okay.
When?
6. This is 10. It's not that much, right? You're past it. All right, so I made a review. Okay, my reviews are optional. You don't have to do them, but it gives you options. I like to give you guys whatever review you have. And then we'll have to paper in there, but a few others.
Okay. Not too shabby.
Here, everyone can get one but Justin.
Harsh. So here's the reviews for the quiz. I have put in onto the Canvas page every assignment from now till the end of the semester. So you can go in and do like the what if scores on the Canvas gradebook. So you can play the what's my grade gonna be game. Because I know that's one of those games that we love to play.
Whoa.
And if you want to do like the final exam stuff, that's these. So if you do that one and you do like the what if games like this, you can get your test percentage, your homework percentage, your quiz percentage, and then do the if I get a 0 on the final, what would happen to my grade? If I get a 60 on the final, what would happen to my grade? It's an estimate. It gets you close because there's like a gazillion things I do in the background to kind of help fluff. But it would give you an idea. Okay? Like it's not dead on. We'll have. I will drop the lowest quiz grade.
Just quiz.
What's up?
Just quiz.
Just quiz. If the final exam, well, if your final exam score is better than your lowest test score, it will replace that. So, just saying. That information is relevant. I've put our QR codes up here. That way it's not the, can you figure out what my grade would be? Nope. It's a calculator. It pulls up a Google Doc. It puts a copy in your drive so you can fill it in. What's up?
You see why clear over there?
What are you showing me?
Show her the peak,
That looks like Miss Diamond. What are you showing me? One of the geometry teachers here. Why